Hi, fifth graders. Welcome to a review lesson from Unit 3. We started Unit 3 on Monday and we've gone through lessons 1 through 4, and this is just a review of some of the vocabulary and situations that we've looked at this week. So the very first lesson had to do with general patterns and special cases, and I've got those definitions right here for you. General patterns are rules that describe patterns. A general pattern can be described in words, and a general pattern may be described with symbols that we call variables. A variable is another vocabulary word, and it can stand for one of many numeric values. So if we have the variable a in one problem, it can stand for the number 3, but in a different problem, it can stand for the number 15. And when a number is substituted for a variable in a pattern, the result is a special case. So remember the reminders I gave you. Think about general pattern as being a rule. And in lesson 4, we learned that formulas are examples of general patterns, that a variable is a symbol, which can also be a number, and that a special case is an example of a general pattern. So when we take that variable and we substitute a number for it, we've created a special case. So here are examples of general patterns and special cases. The general pattern, a times 1 equals a, and another general pattern, n times 0 equals 0. So the special case for this pattern, we substituted 3 for the variable a. 3 times 1 equals 3. 121 times 1 equals 121. And you'll see that the symbol, the variable a, is represented by 3 in the first special case and by 121 in the other case. And we see the general pattern n times 0 equals 0, and then I substituted 5. 5 times 0 equals 0, or I could substitute 2,000. 2,000 times 0 equals 0. General patterns can have two variables. So one example of this would be a times b equals b times a, or m plus n equals n plus m. And this should actually be a lowercase m. And these two patterns actually are examples of the commutative property that we've talked about. So I could substitute for the letter A and the letter B. I could take my pen and I could say if A equals 5 and B equals 3, then 5 times 3, I'm substituting for those variables, equals 3 times 5. And that's an equivalent statement. So again, my special case substituted numbers for those variables. Going forward, another example of a general pattern with two variables. My example is there, and then I've given a special case where I've assigned a value to the variables. And an algebraic expression we talked about in lesson 3 is a group of symbols, and it states a relationship between quantities. An algebraic expression has at least one variable. It can also have numbers. It can have symbols that represent operations like a plus sign or a minus sign. It can have parentheses for grouping and order of operations. Here's an example of an algebraic expression in words. Chan weighs 15 pounds less than Henry, and we're going to let H equal Henry's weight. Now we're going to create that algebraic expression, and I did it right here. H is Henry's weight, so I put that H, and Chan weighs 15 pounds less. So I could represent Chan's weight by H minus 15. Later, I can evaluate that expression by assigning a value to H and being able to figure out Chan's weight. In the second example, in words, Jane has twice as many stamps as her friend Sandy, and S is representing the number of stamps that Sandy has. So S is Sandy's stamps, and Jane has twice as many, which I've shown here as S times 2, 2 times S, or 2S. Now, on the next page, I talk about evaluating an expression. And when we evaluate an expression, we give a numeric value to the variable. And it's very similar to writing a special case. And if I go back here to Sandy, I'm going to assign the value of 25 to S. And then I can figure out how many stamps Jane has because our algebraic expression said Jane has twice as many. She has 2 times the number that Sandy has. So if Sandy has 25, Jane has 2 times 25, or Jane has 50. And if we go forward, we see some additional examples. So on the left, you see in words the algebraic expression, and on the right, you see it written as a variable, an expression of with a possible operation sign. So we see that here and in these other cases. So what I'd like you to do is stop the video, read the statement on the left, look at how it is expressed algebraically on the right. After you've read these and looked at them carefully, you can restart the video and continue. So stop now, look these over, and then start the video again. On this slide, I'd like you to check your own understanding. I'd like you to write an algebraic expression for each of the situations that are listed here, and you use the variable they suggest. So you're going to create the algebraic expression for these statements written in words. So again, you'll stop the video, you'll look at each 1, 2, and 3, and you'll write your algebraic expression and bring that to class. Once you've done that, you'll restart the video. So in lesson 4, we talked about evaluating formulas. Evaluating a formula is very similar to evaluating an expression. We find the value of one of the variables in the formula when we have the values for the other variables. So for example, a general pattern for finding the perimeter of a square is that perimeter equals 4 times S, where S is the side, or 4S. And in this case, this is also a formula. Now, we can evaluate that formula if we know that the side's measurement is 15 and the pattern or formula is perimeter of a square equals 4 times the measurement of the side, then the perimeter of our square would be 4 times 15, or 60 centimeters. So again, we just substituted our value into the formula. Here's another example, and I've kind of drawn a large square with a small square inside it. The formula they've given us is find the area of the large square and subtract the area of the small square to find this area. So we can substitute again. The large square has a side of 4 centimeters. The small square has a side of 2. We substitute those into our formula. 4 squared is 16 minus 2 squared is 4, gives us 12 centimeters squared. So the shaded region around the outside of this would be 12 centimeters squared. So that's another example of how we evaluate a formula. The other thing that we've been talking about at the end of last unit and in this unit is when we divide a whole number and we have a remainder, but we're not expressing that remainder as a fraction or as a whole number, but as a decimal place. And typically they've asked us to divide to 2 decimal places, so to the hundredths place. And I put a problem here, 748 divided by 26. I divided and got 28 up to this point. If I had stopped right here, I'll take my pen and just with this color, if I had stopped right here, I would have had a remainder of 20. But now we have said that we're going to establish our quotient as a decimal. So I had to add a 0, bring that 0 down. 200 divided by 26 would be 7. I multiplied, subtracted. I had a remainder of 18, and my direction was divide to 2 decimal places. So I bring down that second 0. I divide and multiply. I subtract, and I have a remainder of 24. Now I was only told to divide to 2 decimal places. So I have to decide, will this second decimal place remain a 6 or will it be rounded to a 7? I look at my remainder, and the rule is if my remainder is half of my divisor or more, then I'm going to round that place up. So 24 is definitely more than half of 26. So my quotient, 28 and 76 hundredths, is going to be rounded to 28 and 77 hundredths. So I'd like you to try one division problem, and please give the quotient to 2 decimal places. So the problem is 901 divided by 43, but you'll be dividing and listing your quotient to 2 decimal places. So that's it for our review lesson. You'll have 4 problems that you'll need to bring to class, and happy math lesson. I will be preparing the next lesson for our orchestra students who will be missing math. They'll be able to see what we do in class. I will see the rest of you in math class soon.